welcome everyone and thanks for coming along. Today we're going to be talking about MDX Cubes. This is something that's dear to my heart. I've worked on MDX Cubes at places like Trade Me for about 4 years. Prior to that at Foodstuffs, where I built some fairly large models that were the core business models, very, very big data models. I've spent an awful lot of time working on tabular cubes and more recently Power BI, but certainly MDX is a very special place in my heart, and I still think that as an analytics and reporting language, MDX is by far the most elegant of all the tools compared with, say, T-SQL and certainly DAX, which I find, even though I've written a book on it, I find it very heavy, clumsy language compared with MDX. But today's session is not going to be about why I think MDX Cubes are so great. What I'm going to be talking about today is maybe a modern vision for how you can keep your MDX Cubes, or if you are going to build new MDX Cubes, how they might look in a cloud infrastructure. Because let's face it, these are generally the bigger models in your organisation. They are typically running on some of your bigger servers, the inexpensive servers. Most organisations often have a 2 or 3 year hardware replacement recycle, and I think what we're going to see more and more these days are less new servers being purchased for the server room. So what we need to do is find a home for these cubes, ideally in an Azure cloud. As it stands, there is no native MDX implementation like there is for tabular cubes. They are a lot more complicated than tabular cubes, so I understand there's probably a lot more work happening, or a lot more work required to get these up and running in Azure natively. So realistically, the only way to get them running at the moment is on a virtual machine, where you install an instance of, or an install of SQL Server, install SSAS, and then build your cube. So just a quick introduction. Yeah, my name is Phil Seamark. I'm a Microsoft Data Platform MVP. Like I said, I have worked with MDX cubes, very large cubes over a long period. Like I said, I was at Trade Me for 4 years, where there's a very, very big, rich array of data, and we heavily relied on a couple of MDX cubes to be able to ingest that data, simplify it, and make it very accessible to non-tech users via a number of clients: Excel, SharePoint, and more recently Power BI. And for those that were particularly keen, they could hit the data models with SSMS and write their MDX raw, which was always a delight to see. I work for Radicad, and my contact details are at Phil Seamark on Twitter, and my email address there. So if you do have any questions about this in more detail, please feel free to contact me. I'll do my fly in here. SSAS Cube technology from Microsoft is now 20 years old. Well, it will be in November this year. It first arrived in SQL 7 in November 1998, so it's not quite 20 years old yet. It was known, I believe, as OLAP services back then. And then when SQL 2000 came out, when they added data mining way back then, that was practically impossible and very difficult to use. It's much easier to do data mining with the modern tools. Then it was collectively known as analytics services, analysis services. And it's been in every single SQL version ever since. The difference between MDX and tabular models is MDX is a storage-based system, and the underlying technology in MDX cubes, and depending on time we can look at this a little more detail at the end of the session, is really just a big set of summary tables. So you take your fact data, which may be millions or billions of rows of event lines, typically with a date, and what you're doing with an MDX cube is effectively creating a whole series of summary tables, so that when the data is being read into the model, each of these summary tables are being populated to say, okay, this particular aggregation or grouping, add one to that and add a value to the sum. So you could create an MDX cube in theory in a SQL table, but the value of an MDX cube is it takes care of the working out which of these summary tables to use. So when you throw a query to the MDX engine, it goes, hey, I've got 500 summary tables that I can use to answer this. I know which is the best summary table to use. I mean, the MDX technology is an aggregation, but it is the cube version of an index. And it can say, I can satisfy this query that you're giving me by just using this simple summary table over here that was populated as the data was being read in. And that's why it can seemingly answer in nanoseconds what a query that is actually asking a question of potentially many billions of rows. But like I said, depending on whether we have time, I can walk through a SQL equivalent showing as we ingest in some data what's going on under the covers. It's a very mature technology, and as I said earlier, there is no native version for Azure yet. I haven't seen on any roadmap. Yes, it's definitely going to be out end of 1998 or anything like that. It seems to have gone in fits and starts, but what has happened is that as the rest of Azure has matured, we can now do things like spin up some fairly powerful VMs and take advantage of the SQL data warehouse technology. And what I'm going to be showing you today in the pattern that I quite like, the data lake. So being able to leverage Azure Data Lake Storage and Azure Data Lake Analytics to process and make data available to your cube. What's new in multi-dimensional analysis services? Well, with SQL Server 2017, I'm not sure if you can read this at the very back, but it says there are no new features for either of these modes in this release, and it's talking about multi-dimensional mode. So there is, if you're just thinking about your MDX cubes, according to Microsoft, there is absolutely no reason to go from 2016 to 2017. Definitely good reasons to go from 2012 to 2016, but yeah, there is no need. The version I'm going to be showing you today will be 2017 on a virtual machine, but that's only because that was the easiest one to just download and install. I was perhaps guilty of being a little lazy there. So, MDX in the cube. I'll just jump forward to this one here. I tried a whole bunch of configurations. So what I wanted to do was take a typical set of business type data, make a cube, put it into a VM, and just see what were the best ways to be able to refresh and get a lot of data very quickly into the cube. To start with, what I did was I downloaded a tool called TPCH. Now, TPC is an organization that performance tests and compares the likes of SQL Server database engine with Oracle and IBM databases. They get big rooms of 64 machines, etc., and they test how fast, how many transactions a minute they can process, and they typically leapfrog each other. The latest version of Oracle might suddenly now be the fastest database according to TPC, and then Microsoft will jump with an update or a CU with SQL Server. But I use that tool to generate a terabyte of data. So what you can do is download this executable, say, I want terabyte of data, and bang, you let it run, and it creates files, about 8 tables, but these are typical types of data that you might expect for an organization, like orders, customers, parts, suppliers, order lines, etc. And what I got from that was about 6 years of data, and I focused on the order table, which gave me 1.2 billion rows. So we're going to be playing with that today and just seeing how we can get source system data, 1.2 billion rows, into our MDX Cube in the cloud. So we're going to start with this data in the data lake, and what I'm going to do is just jump to that now and kick something off, because it's going to take about 10 minutes to do, and while that's running, I'll explain what's happening there. So I'm just going to jump to my data lake, jump to my VM, sorry. I think I need to just escape from my presentation mode. So this VM, and I'll show you the specs of the VM once this job is up and running. I just want to kick it off. So I have, in my Cloud Explorer, a data lake with a single folder. Now the other two folders, if I jump back, sorry. There are 3 folders in this data lake. Catalog at the top and system at the bottom, they belong to the data lake. They're not folders I'm interested in, I'm working with. The folder that I care about is one called Orders Daily. Now what I did with that orders table of 1.2 billion rows is I broke it down into individual day files and gzipped them and put them into this data lake. So if you can't see at the top, the very top line, which I have highlighted, represents orders for the 1st of January 1992. Now the dates are in the 90s because that's what the TPC application spat out. So and it's an 11 meg gzip file, and if you expand that, and I will download it, and we'll have a look at the file once I get this job underway. So I'm just going to jump to my Data Lake Analytics and kick off a job. So everything can be managed in Visual Studio, and if I jump down to my USQL project, I'm just going to open a USQL script and kick that off. Cool. So that's running. Now it's going to spend about 10 minutes looking like it's doing absolutely nothing, and I'll explain what's happening there. So what I want to be able to do is consolidate my daily files into monthly files. Now the reason I want to do that is because the MDX Cube at the end of the process I have partitioned into calendar months. So I will have, and I haven't built this yet, this doesn't exist yet, I'll have an MDX Cube that will cover 6 years from 1992 to 1997, and I'll partition the measure group into calendar months. So what I want to be able to do is take my individual day files, if I jump up a folder, and what this USQL is going to do from scratch is it's going to cycle through, I'm not sure exactly how many files are in this folder, I don't know if this can tell me. It's going to open all of these files, extract them, and consolidate them down into 64 monthly CSV files. I'm not going to compress them because I'm going to be using the SQL Data Warehouse to give access to the MDX cubes to these files. And at the moment, SQL Data Warehouse doesn't support opening gzip files, but it doesn't create a huge amount of data. And actually, at the very least, it's a demonstration of how well the Azure Data Lake Analytics can do some processing, such as take 2,228 zip files, open them all up, and give me monthly files in the format that I need. Now the syntax for that, if we jump back to the USQL, and please actually, if you have any questions about any of this, feel free. Like I said, I do have chocolate available for helpful questions. But let's have a look at that USQL script. At the moment, what I am doing is a fairly ugly syntax, which is to say I want to extract from files in that folder, my orders daily folder, and the very top line is going to look for any file with a pattern that matches 1992-01. So what this is effectively going to do is grab all the 30 files or 31 files for January 2002 and put them into a variable called in 1992-01. And then my next statement is just going to straight spit that out to a CSV file in a folder called this and a folder called this. Now this isn't very dynamic code. I had to pretty much generate this script using a string generator actually in SQL. So I have 64 of these lines, one that represents each month that I want to generate. There is a private preview of what they call a dynamic partitioned output, which means this exact same script can be achieved using this syntax here. This was released about 10 days ago. It's in private preview. This works at the moment so long as you only use about 30 or 40 files. When you start throwing 2,300 files at it, it comes up with errors, and I fed that back to the engineering team, and they said, okay, yeah, we'll look into it, but it hasn't been fixed yet. But the intention is for you to be able to write much simpler USQL, and this would be dynamic as well. So this particular set of SQL would allow you to just every day keep adding another one-day version of your sales file. So, you know, this morning you might upload the sales for the 13th of January 2018 and just drop it into the folder. And actually what I'm doing here is I'm processing the entire data set every day. You wouldn't necessarily need to do that. You'd probably only need to do the current month or, you know, a couple of recent months. So what the USQL is doing is it's taking each individual file, it's fanning it out to all the logical processes and PCs that are available to Azure Data Lake Analytics. How that works, there are server rooms full of I wouldn't say huge machines. They're probably, I think that they have about 6 gig of RAM, 2 CPUs, but they have just thousands and thousands and thousands of machines just sitting there waiting for these jobs. Now, what has happened here is what I have asked USQL to do is the script. The Data Lake Analytics takes the script and organizes a bit of a plan. This is all oblivious to me. I don't have to code for this. And it distributes the work across as many machines as it thinks it needs. You can control whether you want to use a lot or small. The more you use, the more it costs. And then by magic, what we will see is the result. It's well worth looking into, not even for MDX. It's quite a powerful way to process data. So let's just see how that's going. I'm viewing my job process using Visual Studio. I can also jump into my the Azure Web Portal, and I can go to the Data Lake Analytics blade and have a look at all jobs that are currently running. I can look back at previous jobs and diagnose them, pull them down and break them apart to see some really interesting things here. And what we can see is my job is still preparing. So at the moment, all it's effectively doing is it's sucking up those individual daily files and it's throwing them out. It's copying them across to all these worker machines. And in about 9 minutes or 10 minutes, it's going to start working, and it should only take about a minute or two to actually do the work. And then once it's complete, what we will have is a new folder in our Data Lake Analytics called Orders Monthly with 64 CSV files. So does anyone have any questions about that aspect of the data prep and getting it ready? Cool. The good thing about this pattern is the files that are created by this are the files that are going to be used by the Cube to read the data in. I'm not going to be copying them to any other place or introducing another process. So as this Data Lake Analytics job completes, bang, I can go to the Cube and say, right, I want you to now start bringing that data in. That process there seems to take about 8 minutes as well, but it's there's at least a little bit more visual going on, and we can talk about a few other things. So I'll just jump back to the Visual Studio. So it's still very much in preparation mode. When I tried this a little earlier in the day, it did take about 9 or 10 minutes to get through this. If I really run out of things to say, we can switch across to the stuff quiz and see how we go as a group. But not for those who have maybe already done it this morning. Okay, so back to presentation. Okay, so what's happening is we're taking advantage of the USQL script, although I haven't written any USQL. All that I'm doing in the script for this example is say I want to extract some data from files sitting in the data lake, and I want to immediately output the data. Typically what you would use USQL for is write SQL-like manipulations to that data. So while it's been imported into the variables, you can start doing things like counts and joins and left joins and groups and cross applies and all the wonderful things you typically can do in SQL. But you're running across a huge amount of data, and it's well worth having a look at. The data lake itself, pricing-wise, it's approximately $35 US a month for 1 terabyte. That's retail, so if your organisation does have a good spend with Microsoft, you can often negotiate that down. And it's not, it gets cheaper as you use more data. So if you start using the Data Lake Analytics more for more and more and more data, it gets cheaper and cheaper and cheaper. But when your data is sitting in the Data Lake Analytics, it's not sitting on individual files, it's sitting on a HDFS Hadoop distributed file system. So it does mean any processing that you want to do on those files are very, very fast. A bit like BitTorrent, but in files and all in one place, because it is spread amongst a lot of machines, and that's the thing to actually leverage. Certainly a lot cheaper, I think, to keep this sort of data in a data lake than perhaps one of a big version of a database, especially if the reason you want to keep the data here is for doing things like data lake, for analytics and reporting. If your intention is to do lots of inserts, little one-line inserts, updates and deletes to a huge amount of data, this is probably not the technology you're after. This best suits perhaps when you just want to get your source system data out of, or get your data out of your source system and keep it somewhere, accumulate it and make it available for standard processing jobs, but also ad hoc work as well. A job I was recently, or a job I'm working on at the moment for a government department down in Wellington, they spend a good amount of money buying this information. Once a year they get a disk with 3,500 zip files. And each of these individual zip files has about 20,000 files inside them. These 20,000 files are all complex XML, and at the moment, when they want to extract information out of these XML documents, these little mini files, which there are a lot of, it takes them about 6 weeks, because what they do is they wrote this process to start with the first one, unzip, then go through each individual files inside, and it takes a long time. And I said, hey, give me some of your files, and in fact, give me all of your files. And I put them into a data lake, and about 3 hours later, when I'd written the USQL code, I hit the go button, and it was under an hour. It was able to fully extract, open, parse all these files, look through all the XML, and spit out the data they actually needed from it, which is, I think, quite impressive for data lake analytics. And for someone like myself, who comes from a SQL background, jumping to USQL is very familiar, and it does make life a lot easier. Okay, we'll just jump back into the virtual machine and see how that job is going. Okay, so the preparation step is finished. That took exactly 10 minutes, so that's fanning out the 100 files. And normally, the visual display you get here is not so wide and thin, because you're perhaps dealing with not 2,500 individual files. But what we can see here is it's 99% of the way through the actual processing of the data. If I refresh this now, which is I think on a 30-second schedule, it may almost be done. Let's have a look to see if we can see anything in the output folder. Refresh. Here we go. So in my orders monthly folder, which didn't exist before, I now have a whole series of folders. My USQL instructed it to create a folder for each file, and we have a CSV file now. This CSV that I've randomly chosen is 1.4 gig. So if you can imagine, we've now got 64 of these. What are we talking about? 100 gig of data that we've been able to process from scratch in a fairly short space of time. Admittedly, I'm not doing lots of manipulation to it, but that is not something that would typically slow it down a lot. So let's see if this is finished yet. Okay, so that's done. So if I wanted to reprocess in full every single day, I could just kick off that job, and 12.1 minutes later, it would be done. I could reuse the whole lot. I could delete the folder and reprocess the whole thing. Realistically, I'll probably script it to just do a couple of folders at a time. It would still take a minute or two, because it does a lot of this in parallel, so it still will take at least the amount of time to grab 30 files, unzip them, and process them through. But I think that's quite impressive. Now, these files that I've created are what I'm going to be using for my MDX Cube to suck in. So a limitation with MDX Cubes is it doesn't have the ability to talk to a wide array of data sources like we're used to with Power BI and even tabular cubes. It's limited to a handful of the big databases, but you can't even perhaps, if I go new data source, there's not a lot, but a SQL database is what we're going to be using here. And what I'm doing with my model is I'm connecting to a SQL data warehouse, but I'm not going to be grabbing any data from the data warehouse. What I'm going to be using are external tables within the data warehouse, which are configured to point to these individual files. So I'll show you what that looks like. So if I jump to my SQL data warehouse, I have created, when this catches up, there we go, a series of external tables. So each one of these individual tables is mapped to one of those files. So if I want to add a new one for January or February 2018, I would just need to create an external table to be there. That can be easily automated via script. And if we look at what the script might look like, drop and create. It is just a create external table, defining my schema, and it's specifying the folder that I want to look at to get that data. Now this means at the moment, I can query this table. And when I issue this query, select top 10 star from that table. What the SQL data warehouse is going to do is use Polybase to go and find that file in the data lake that we just created. It didn't exist a moment ago, and it's going to give you that SQLite query and response experience. So you can, here at this point, start writing joins and groups and all sorts of clever things in SQL Data Warehouse. But for this demo, no data for the cube is actually sitting inside the SQL Data Warehouse. So you can pause this, you can scale it up and down, and you're not going to get charged for an awful lot of data because that's all sitting outside in the data lake store, which would also equally be available for other systems. So Power BI Desktop can connect to files in the data lake store. I'm not sure if you'd want to connect to a 1.2 gig file or lots of these 1.2 gig files. You might want to summarize these down a lot before you do that. But there we go. So I've just written a query inside SQL Data Warehouse against the file that didn't exist 10 minutes ago. And I can do counts, all the things you might expect to do in SQL. So let's jump to our queue. I have on the local host of this virtual machine an empty cube. So if I minimize my SQL Data Warehouse and we see that I have a cube, come on, come on, come on. I don't know whether if this is slow Wi-Fi or if this is my VM melting down. It's a I think it's my SSMS. This particular VM has got 32 cores, or 32 CPUs, virtual CPUs, and plenty of memory, 128 gigs of RAM. We're not going to use the RAM at all for the refreshing of data, but that might be useful if some of your cubes are getting heavier workouts, heavier workloads. But I more just want to show how you can quickly get data in. This is by far nowhere near the biggest machine you can spin up in Azure VM as well. So if you find that you running your cube and people are complaining that it's slow, you've got two paths to do. You can either try and optimize through better and smarter aggregations, or you can say, let's just restart my VM and give it 64 CPUs or 500 gigs of RAM, or both. But that's an awful lot easier than perhaps knocking on the door of the server room and say, hey, can we have more disk or can we have more CPU? Because like in most organizations, you probably get the big fat no. My cubes of, here we go. Now I have an order partition, an order measure group, sorry, and this order measure group has no partitions. I'm not sure why this is running slow, but if we refresh this, we can see that we have no partitions. And if I jump to a little bit of MDX, from an earlier test, you can see there are results there. But if I run this query, F5, no data, it's empty. So we have an empty queue. So jumping back to the same Visual Studio that I was using earlier for the USQL script, I have a project in the solution for the cube. So I'm going to deploy that. Which, as you know, is probably going to wipe my cube anyway. Where is my deploy button? Right at the top, there we go. There is no MDX script defined in this cube. Okay, well, we'll just go deploy. Cool, we're going to overwrite it, yep. So what I do to create partitions is I usually in my cube have just a single template partition. So if we have a look at what that looks like in the cube, there It's just a single petition which I call template, and it has a dummy piece of SQL which I use in script to clone and copy and just adjust the where clause for the script to align. So I'm going to jump now to a console app that uses AMO objects. So I have a small script here that says connect to my server, and then for every server, go through every single database. I only have one database in this server. Then for every database, for every single cube, and I only happen to have one cube in this database, cycle through every measure group. I only have one measure group, but I might have multiple. Within that measure group, look for a petition that has the name of template. And if you find one, go into a bit of a date loop. So start with 1992-0101, so January the 1st, 1992, and finish 5th of 1997, and look for do some string replacing to generate some partitions. So I'm just going to kick that off. It only takes a second to do. Execute, debug. Oh, it's here. It's on the actual thing. So the purpose of this is just simply to create the petitions. But I'll show you one petition why this is important. We jump back to our Server Explorer. No, we jump back to SSMS, find the cube, we refresh the partitions, and instead of having no petitions, I should have 65 petitions, the single template one, and all these that were just created. And if I pick one by random, we can see that the SQL that I have generated is specific to that partition. So for April 1992, this is the query it's going to issue to the data warehouse. It's going to query a table called dbo.orders_1992-04. Now this happens to be an external table, which is just going to go and find that file that we created in the data lake store. So if I had a look at some of the other petitions, the SQL that has been generated is appropriate. So let's kick this off. So I'm going to process the other speakers are hogging the Wi-Fi. Okay, so go over here. I'm going to kick that off, and I'm going to do a process data. We'll come back and do indexes later if we need. So this here is now the point where we're sucking data in. So this is 1.2 billion rows of data sitting in 100 gigs of files in a completely different system. It's in the Azure Data Lake store, so it's not on the same machine as the VM. The VM has been created in the same region, although what I found with testing is when I had, say, a data lake store in the US and I had my VM in Australia, it made no difference, because what I'm going to cover next is the bottleneck, strangely, is with the SQL data warehouse. The virtual machine that we're using is more than capable of handling the amount of data that this is going to throw at it. And in fact, what we'll do is we'll fire up the CPU view. So we can see the 32 CPUs are not busy yet, because the data warehouse, remember when I issued that query against the data warehouse, it just seemed to take about 30 seconds before it responded. At the moment, it's just sending those queries off to the data lake store, and what we're going to start seeing is bang, 32 petitions will start filling up. And at the moment you can see there's no network there. So here we go. We can see some partitions starting to come in here now. So if I leave that alone, you'll see how quickly it is actually reading in, and the CPUs are now starting to pick up. Now, the SQL data warehouse has a limit at the moment of 32 concurrent queries that it will allow to run at any one time. I've just filled up all 32 slots with these queries. So if I went and queried an actual table in SQL Data Warehouse right now, just go select top 10 star from table, normally, bang, you get a result, so long as that is a table within the SQL Data Warehouse. At the moment, that would be paused and blocked behind this work. But that's the nature of doing a full cube refresh. And this actually caught me off guard. When I was originally doing testing, I was using the SQL Data Warehouse, and with Azure you can set the DTU limit, and I had this set to about 500, And when I ran this, it would, in fact, actually, I think I had it set to 100 initially. And when I kicked this off, because I knew that it wasn't going to be heavy work on the SQL Data Warehouse, it only let me run 4 partitions at a time. And when the first one finished, it then started going to the next one. And then when that one, when another one finished, it was first in, first out. With SQL Data Warehouse, as you increase the DTU, that's where you increase the number of concurrent queries. So what I found, and I hope you can see this here, is that when I could set the SQL Data Warehouse to DTU 1000, that allowed me to get to the highest number of concurrent queries. What I really want is for it to have 64 concurrent queries, so that when I run my 64 partition cube rebuild, they can all run in parallel. But what's happening at the moment is the first 32 are running. They're going to run in full. And when the first one drops off, then the 33rd one will start running. Let's just jump back to see how that's going. But it does show that you probably, maybe if you are looking at moving your MDX cubes to Azure, some thought just needs to be put in place about maybe your partitioning strategy and how that might work with the current configuration of SQL Data Warehouse. I complained to Microsoft. I said, look, hey, this is really cool. I can spin up a 64 CPU machine, powerful CPU machine with lots of RAM. I can say I want a machine with a really fast networking, view network details. I'm not sure if you can see this here, but this is using accelerated networking. This is a 40 gigabit connection, and we're only using 1% of that. So the network is not the bandwidth. And but what they came back to me with was they said, well, realistically, SQL Data Warehouse is not designed to fire hose data out of. SQL Data Warehouse is really good to load a huge amount of data in and do processing internally in SQL Data Warehouse. So you can start with very, very large files, trillions of rows, and create other tables, with trillions of rows, and it handles it beautifully. The problem that SQL Data Warehouse has at the moment is that it's not designed to quickly get data out of it. When I say quickly, I'm seeing transfer rates of about 200 to 300 megabits per second. That is going to be improving. They are going to be doing things like increasing the concurrent node, the maximum concurrent node above 32, plus they're going to be increasing the ability for SQL Data Warehouse to throw data out. But as of today, the best that you're going to get is this speed. And that's not polybase either, because in the various configurations I experimented with, I did things like put all that order data into a table inside SQL Data Warehouse. So I didn't have to worry about firing up polybase, talking to data lake stores. And it was the same output speed. The limitation was this is not polybase or data lake store that is holding back the speed. It's certainly not the VM or the networking, it's the data warehouse. But unfortunately, polybase only exists in the SQL Data Warehouse, and MDX cubes can't talk to the data store automatically. So the reason why I like this particular pattern that I'm demonstrating today is because it's nice and simple. You can start with your raw data as daily files, zipped up, and just leave it alone. Just accumulate that, add to that every single day. Do one operation to process that into data that's optimized for your cube, and that's it. You don't move it from there. You don't need to copy it anywhere. You don't need to put it into blob. You don't need to do anything. Once that's complete, you can kick off your model, and it can start bringing the data in. So if I have a look to see how this is processing, like I said, there's about 32 here. One of them looks like it might have finished, so the 33rd one will start going, but the 34th, 35th, 36th ones, they should all start pretty much in tandem. So does anyone have any questions at this point? Yes? Oh, so a hard install? Yeah, so yeah, I definitely did that. It's a good question, and it was awful. So on this virtual machine, I put it up to 64 CPUs. I have SQL Server 2017, so initially I only put in SSAS, and then I added the database engine and I added polybase. What I found was, and I pointed the polybase data to a blob version of this data and also SQL data lake store version of the files we're looking at the moment. Polybase just maxed out the CPUs, just like everything just maxed out, and it was horribly slow. The best I could get was 4 partitions running in parallel, and it was going to take hours and hours and hours. I don't know if that's a bug or something that I maybe did wrong, but I just did a vanilla install of, I want Polybase, and I'm going to create a whole bunch of external tables, exactly the same way I did with SQL Data Warehouse, and pointed them to the exact same data source. But yeah, sure, when you looked at the CPU, 95% of the CPU was Polybase going nuts. The database engine was fine. The cube was not the one that was actually causing the problem. And again, the networking was, I'm only using 1% of the potential network available here. I can browse to, say, my Visual Studio and say, give me an ISO for some operating system, like an 8 gig file, download, bang, it comes down really, really quick. And it has no impact whatsoever on this activity here. So it's that bottleneck. Now, I might sound like I'm ungrateful, because at the end of the day, being able to get 1.2 billion rows into a cube in, say, 8, 9, 10 minutes for this phase is not terrible. It's still pretty good. From my experience, some of those big cubes that we worked with, like I said, Trade Me, when we had to do things like make a structural change to the cube, we're doing a new deploy, we're adding new dimensions, or we're making a change that meant we had to effectively build a new cube from scratch, refill it up. We're talking days. We're talking 3, 4 days, and you're watching these things. It's a lot of work, and we had some they had some pretty big machines in their server room. Not cheap. They were spec'd up, but they certainly can't compare with the infrastructure that you've got at your fingertips with the data lake analytics setup. Where the data is spread across, I think it's about 60 machines. And I think the data warehouse, when we are issuing these queries, they're running across many compute nodes, so it can just spread that Polybase out. And I don't expect that it's an easy thing for them to solve, but they are aware of it and they're working on it, and they're going to be making this better, not just for cubes, probably for other things that might want to talk to SQL data warehouses at the moment. But as it stands, you can get this. And like I said, what I found was I tried all sorts of different configurations, putting the data into SQL Data Warehouse, putting it in blobs, putting it in the Data Lake store, trying daily petitions, quarterly petitions, monthly petitions. Didn't seem to make any difference. They all seem to be around the 200 megabit, 300 megabyte transfer. So I thought the reason why I like this pattern that I'm showing you today is because it's really simple in the way the data is organized. There's not a lot to script to maintain it. It's only in a couple of places. And you can just, like show you, just dump the folder, bang, you can recreate it in not much time at all. So how are we going here? We started this at 9:04 and it's 9:14, so it's taking 10 minutes. I have seen this and probably I've tested this exact process maybe 5 or 6 times, and I've hit sub 8 minutes a couple of times. Maybe it is dependent on what else is going on in the SQL Data Warehouse or the Data Lake Analytics store, but like I say, it's still pretty good, and being able to fit it in the session is good. I'll just jump back to the slides to see if I've forgotten anything, because I have been kind of jumping ahead. So we've looked at the fact that it's file-based storage of data. We're using daily files, we're using USQL to bring it through. The dynamic petition output is going to make much simpler code. It's not going to make it run faster, but it means the USQL code is going to be more elegant. Azure Cloud Explorer is a tool that you previously could use to look at data in blobs, but as of today you can connect to Data Lake stores and look at folders and download, upload. So it's a new feature that I picked up this morning. It's a good way to get data in and out of the cube. Here's the step that we're running at the moment. So we're taking monthly CSV files and we're just using Polybase to pass the data straight through SQL Data Warehouse. Now once this is finished, because SQL Data Warehouse is more expensive, we can hit the pause button and billing stops until next week or tomorrow, when we can hit the unpause button. And this is something that can be scripted via PowerShell and whatever else, or Data Factory, I guess, to as part of a longer flow. So we could use a data warehouse just for the process of this. Pause and scales, we just mentioned. External tables, that's how we're using. I mentioned the concurrency limit of 32. And importantly, there is no need to actually store data in SQL Data Warehouse. You can, if you want to, but for this, You don't actually need to. And the MDX Cube, of course, I've deliberately partitioned so it's in alignment with the data flow upstream. We looked at. Yes. It's not instant, but it works. So you can query it. Now, a lot of people say you might use that create external table as a method to get data from those data lake store files into the data warehouse. And once it's in the data warehouse and you go, say, select top 10 from table, bang, you get instant results. Whereas while it's still in the data lake store through the polybase, it sort of takes about 30 seconds. But if you say just a light query like select top 10, it takes 30 seconds. But you give it a harder query, something a bit group in this and do a lot more work, maybe takes 35 seconds. It's not, there's a overhead that's just always there, but everything beyond that is simpler. And yeah, I would definitely look strongly at perhaps put your source system data into an incoming folder in your data lake store. Use processes like the data lake analytics, the USQL, to create multiple sets of files. So you might create a set of files that's designed to get the data into the cube, but you equally create some sets of files which are fact and dimension tables, and you expose them. You allow people, perhaps, depending on your preferences, you might allow people with Power BI to connect to those files directly. You can create all sorts of summary files. You can give your Power users the ability to just write their own USQL and output to their own folders against the raw data if they want to. If they're familiar with the data and they know what they want, they can be using during the daytime when the ETLs are all done to create interesting analytics. And like I said earlier, you can do a lot of interesting processing in a very short space of time. It's well worth looking into. Yeah, and it's cheap. $35 for a terabyte for a month is a lot cheaper than perhaps internal infrastructure. And you can just keep adding and keep adding and keep adding, and there's no limit. Whereas I think on the blob side, if you do start throwing more files at some point, it's going to say, no, I can't fit any more in, and you've got to create other blobs. You can just keep adding to data lake store. And you don't just need to use it for source system data. You could use it for all sorts, but it's probably, its sweet spot is take your source system data, accumulate it, just constantly add to it over time, and then you can use the USQL and Cube technology to really get into it. Sure.
Can you use PowerShell to do those USQL file movement like operations?
I believe so. Yeah, I think I'm not a PowerShell aficionado, but there doesn't seem to be much that you can't do with PowerShell, particularly with Azure. And now there's an Azure-based PowerShell as well. There's an Azure one, but I haven't actually used scripts to do that. Perhaps my comfort zone is more Azure Data Factory, or now the SSIS packages inside ADF2. But I would be very, very surprised if you couldn't do that in PowerShell. So. Yeah.
How many rows of data is that?
Oh, billions. We're talking 15 to 20 measure groups, and each measure group might be, 40, 50 billion rows. Yeah, a lot more. And part of the problem we had there was because space was a limitation, compromise needed to be made in the database to do left joins on the views that the cube would see. So in an ideal world, your fact table would have every single column it needed inside the fact table. And your next fact table might have a lot of the same columns. There's a lot of duplication. And if you were to repeat that out inside your on-premise database, your database footprint is going to be massive. But to get around that, we could say, right, let's effectively create views for the fact tables that made the appropriate flattening joins. And the penalty was the views were more expensive in terms of running time, particularly when you're joining very large tables with very large tables. Ideally, if you could have unlimited space, you could just say, right, we're going to create the physical fact table with everything it needs, point the cube at that, partition it appropriately. But I doubt we would see the speeds that we would see here The bottleneck perhaps might be maybe more networking, just physically getting across the file, because even though you can partition the file within your database, unless you're running maybe an on-premise MPP system, one of those big parallel systems, you know, it's just physically can't parallelize the data flow it needs. So whereas that's not so much of an issue in the Azure world. I mean, in early cloud days, it was very much in feature mode catch up. You know, it was like on premise you could do a huge amount, and cloud was always catching that up. You know, now very much it's overtaken, I think, particularly in the era of being able to take jobs and fan them out over many machines. And I think USQL is very good at that, and even just virtual machines. Let's jump back to that VM and see how it's going. Well, hey, so we've finished, and that took 12 minutes to read in how many rows? Let's query this. Oops, F5 button, not F4 button. Now, I haven't added any aggregations. So this is not going to be a blindingly fast query, but it will give us back the result set. I might stop that, because what I want is the sum here. 250, 250, 250, 250, 250. So we've got approximately 1.2 billion rows of data there that we've imported into an MDX Cube, in a VM, in the cloud. We were able to create the data from scratch. The data was very simple in its formatting all the way along. So I think that's quite a nice pattern. Should we add aggregations? Does everyone have a sort of fairly good idea about the technology underneath the cubes, about these summary tables? We can probably have a quick look at that if you like. We'll see how we go. Open recent file. How aggregations work. So, let's pretend that this very simple 3-column data set with a date, a category, and a value has many billions of rows. I'm just going to, I have a data set with just 9 rows here. Now, if I import that data straight into the cube, and then I ask a query of the cube, like I just want to sum the value column, sum the value column by category, or just count the rows, the cube still needs to actually look at every single row, which it can do very quickly. You saw me run that query before. It took 16 seconds, but that's not typical of an MDX Cube. A well-optimized, well-oiled MDX Cube should be always never more than 2 seconds, with a couple of small exceptions. So what the cube does is you can create aggregations. They're like indexes for database engines, but let's say I'm going to create a table which is going to be an aggregation of this data. I'm going to call this table ag year, and this table is just simply going to aggregate the data down to year, nothing more. That's all it's going to do, is worry about squashing this 9-row data set, or 900 billion row data set, down to 1 row per year. And for that table, it's going to keep some statistics like what is the sum of quantity for that year and how many rows have we counted. For a second aggregation, I'm going to create one called, and these are just hash tables, I'm going to aggregate on year and category. And for this table, I'm actually going to aggregate on year as well as category, and keep my metrics, the sum, etc. So I'm going to, and I have a procedure. What the procedure does, and I'm not going to go through this line by line, it says when I get a single row of data, I'm going to go have a look at my category table and say, have I got the year or category in my aggregation? If not, add that as a new thing, put the value of the value column, and add the counter to be 1. When the next row comes in, if it happens to match the same year, it goes, right, I've already got that line in my aggregation table. I'm not going to add another row. I'm just going to increment it appropriately. So if I run this to create the temporary store procedure and the temporary tables, this is on a local machine, so this should be sub-second. What we're going to do is walk through adding these line by line I say, let's process row number 1. And this is on the local machine. So on a local machine with 32 gigs of CPUs and lots of RAM. It's certainly not busy. Okay. I have a drop. Is null. So I'm not using the SQL data warehouse, I'm just using a local install of SQL 17. Oh, go away. Create procedure. No, I need to connect to, that's why it was taking a while. Let's connect to my local machine. Fat fingers. Okay, cool. So the first line of data that we have is 1st of January 2016, A and 5. So we process that line and have a look at our 2 aggregation tables. What it has done is in the year one, it's created the line and it said, okay, the value is 5 and the counterfactor is 1 and the one underneath, same thing, it's broken that down. So let's now process line 2 and have a look. Process line 3 and 4. So what we see now is the aggregation table that we're maintaining has now got 3 lines, 1 for each year and row. Now, if we finish that off, what do I do there? Was it 4? 1, 2, 3, 4. So 5, 6, 7, 8, 9. Okay, cool. Now with year, that's a fairly aggressive amount of aggregation. But if my fact table had 900 million rows, and I wanted to say I want a count of rows or I want a sum of the value column by year, rather than go to the raw table that still exists in the cube, what I can do, if my query is just by year only, I can go select sum of year quantity from ag year. And that's going to be much easier for the cube to provide the answer to the end user. So rather than taking, say, 16 seconds, it's going to take, no time at all. But if I extend my query and I say I want to also get the category and group by category and run that. Sorry, fat fingers. I think maybe I need to call this year and oh yeah, because it doesn't work. I can't query on category on the year aggregation because it doesn't exist. I have to go to another table. Yeah, good point. So when you're writing your MDX queries, effectively the equivalent of the execution plan or the query engine is not only necessarily making a good plan, it's saying what aggregations exist in the cube that I can go to satisfy this query and shortcut it and well. Now, this is where it has an edge over tabular cubes. So if your data sets are particularly large, particularly complicated, you can be clever and smart with your design of aggregations to still satisfy quite a decent range of queries from aggregations as opposed to raw data. Whereas tabular cubes still would pretty much have to table scan, and the more complex the queries, the slower and more complicated things get. So, this is sort of the sweet spot that MDX satisfies. What I think tabular models are good at are small models, medium-sized models, and large models, but only if the data is simple. Once the data becomes complicated, particularly like financial scenarios, then MDX cubes, that's where they really start to hit their sweet spot, which you probably know as an audience, and I didn't want to spend too much time on that. I was more sort of keen to show how you can lift and shift your exact same MDX Cube that you run right now, put it up into a VM in the cloud, and as long as your data is also in the cloud, you'll have a fairly nice, simple, easy model to look after and maintain. So if we've got time, I think we've got 15 more minutes. What I'll do is I'll add the aggregation to the MDX Cube live and kick that off, take some questions, and then we'll run that same MDX query that I had earlier, but this time it's going to take advantage of the aggregation. So I'm going to open my 2017. I'm going to connect to my live cube, open analysis services database, my local host cube. I'm going to go to my Difinity cube, and I'm going to design aggregations. This has none, which is really inefficient. I'm going to add an empty. This aggregation has none in here. I'm going to add an aggregation, and I'm going to simply say I want to add this on year and region. So this is the equivalent of me creating that hash table that we just created in the SQL script. I'm going to go OK. I need to assign that aggregation to the petitions. So I'm going to now say I want that aggregation to belong to my 64 monthly petitions. Save that. So I'm doing this on the live cube now. People could be querying the cube, keeping it fairly busy, albeit this particular cube would be slow because it has no aggregations. Now what I'm going to do is over here, back in the cube, rather than a process data this time, I'm not going to reread the data in again. I could go and pause my SQL data warehouse. SSMS, Server Explorer. Come on. No, it's SSMS, this guy. I'm going to go to my orders measure group. I'm going to kick off a process data, process index, which will just take the data it's already ingested, those 1.2 billion rows that are stored within the file-based cube at the moment, and it's just going to generate these temporary tables. So it's a bit like how I was running that stepping through the example in T-SQL. So this should be a lot faster than the process data because it's all nice and self-contained. There's no limitation in the SQL data warehouse. Plus, I'm only adding one aggregation. I expect that your MDX cubes might have, some of your measure groups might have in the order of 300, 400, 500 aggregations, depending on how heavily these are used. If you don't know, you can take advantage of some of the features inside MDX to help design these aggregations. You can turn on a feature called store everyone's queries to the query log and point it to a database table, and it just stores the binary signature of every single query. The binary signature is useless to you to read. You can map it if you really want to, but you can tell that editor that I was in, I want to create aggregations based on these signatures, but only use ones that took more than 5 seconds or that were on this particular measure group. And that can give you 30, 40, 50 aggregations, save, process, bang. The more aggregations you add to your model, the more work the cube will have to do as it's importing data each time. So if you have really low-level granularity on your aggregations, that will be noticeable on your cube refreshing. So that's a bit of an art form and probably a session in its own right. What are the best approaches to optimizing my aggregations on an MDX cube? But while that's processing, how about questions? Does anyone want to look at anything at all about that? Hello. That sounds right. I couldn't say off the top of my head. So the question was, or the suggestion was that for a while now, there hasn't been any development to the language. So I know, for example, for DAX, every time they release a new version of Power BI Desktop, sometimes we see some new features and functions appearing. With MDX, no, I don't think I've seen something for a very long time. It has been around for 20 years. So, you know, probably in the first 5, 6, 7 years, there was a lot being added and people saying, hey, I've got this complex data scenario that I can't do because of the limitations in the language set. A lot of that to and fro and back and forward has taken place a long, long time ago. So maybe it's not necessarily a reflection of it's being decommissioned. It's maybe just we're not seeing the ideas and the requests and the suggestions perhaps coming in. Sorry? More of a chore? No. Oh, more mature, yes. I thought you said more of a chore. Some people would agree with you. Yes, I know. I do love it. I actually find it, because I've come from a software development background, and I find it a very elegant language in terms of you can get away with writing very little MDX to be able to do an awful lot, whereas like I do find particularly DAX quite cumbersome and heavy and almost sort of like in gumboots. It works, and it can work very, very fast, but I'm just maybe biased and a product of my background. So there we go. We've effectively built our hash tables across our 1.2 billion rows. So I'm going to jump back to my MDX query now, and I might turn on Profiler so we can see. And I'm going to just turn Profiler on against my localhost cube, just get that running, jump to my MDX cube, hit the rerun button. Remember, this took 16 seconds. And bang, that was instantaneous. And the reason why it was instantaneous is because when I find Profiler, I didn't turn on the necessary event. You can turn on the events to say whether it's doing partition reads or whether it's doing an aggregation read, and it will tell you which aggregation it has actually used to satisfy that query as well. So you can see whether that's working. And you can also apply clever aggregation strategies to say 2018 and 17 data can use these aggregations, but older data use these less aggregations if you want to save footprint. But that's, like I said, a topic for another session. So other than that, I will be around after the presentation. These are my contact details, both in Twitter and email. Please feel free to contact me if you have any questions about MDX, SSAS, Azure, USQL, or even DAX. Hello. No, it doesn't. And I'm not sure it's going to. I think coming along, they are going to have something that sits in between. I was having a discussion with someone at Microsoft yesterday saying, okay, you can install SQL engine into a VM, just clean like you might have on-premise, and you've got the PAS instance, but there might be something that's a little in the middle there that might have Polybase. Yeah, so if that comes along and that has Polybase, then that's a cheaper alternative to the SQL Data Warehouse, because in reality, as soon as this presentation is off, I'm going to just pause that SQL Data Warehouse and don't need to use it again. Yeah, exactly. You kind of want to keep it in maybe the data lake and maybe look at doing much more processing and managing of your data. I mean, it is optimized for analytics and reporting, where you're not doing lots of little one-line inserts and deletes and updates all over the place, so you don't need that big complex database engine that can do those sorts of changes. All you really care is let's have a big file over here, and let's create a big file over here and sort of just move it as a one-off operation, and we can merge it with these other big files over here. But so that's the sweet spot of data lake analytics. Yeah, and I think a lot more data warehouses will exist that don't use a database to store those fact and dimension tables or the raw source system tables or even the intermediary steps. You don't have to delete those intermediary steps. You can keep them if they're useful for power users or data mining or whatever. So it's, well, totally, yeah, and it's fast. Yeah, thank you all for coming, and I hope you really enjoy the rest of your Difinity. And yeah, like I say, just reach out if you have any questions. I'm more than keen to help out. So, chocolate. Come up and see me, and yeah, if just ask the question. Sorry, stop. Come and grab some chocolate. So, and feel free to share. Thank you.